In question 16, you're asked to represent each of the following cases of a sequence rule, then find the first 5 terms. Now, in A, you know that A is going to be $12,000. Now, if that's invested at 7% per annum compounding every year, then R is going to be 1.07. Now, when it comes to representing that as an equation, we've got the following. T to the n is 1200 times 1.07 to the n minus 1. Now, I can generate that pretty readily on my calculator, and you can easily write out the first 5 terms. Now, just a little word of caution. When we represent this, that's 1200 at the start. So that will be after 1 year. So a little word of caution when you're working or using a geometric sequence as a compound interest generator. We'll normally use, of course, the compound interest formula, which surprisingly enough looks quite similar. So when we record that down on a bit of paper, you can see the growth of it. So initially after 1 year, 2 years, 3 years, 4 years, just be a little cautious there. In the case of C, we've got a weed killer. We start off with 7,000 thistles, and the common ratio eradicates 25%. So 1 minus 0.25, or R is 0.75. And that will give us the equation to the n is equal to 7,000 times 0.75 to the n minus 1. And when we enter that into our sequence mode on the calculator, you can see how we start with 7,000, then each eradication, 4, 9, 3, 4, etc. So we initially have after 1, after 2, after 1, after 2, after 3, after 4, after 5 applications. In part E, you've got a culture of bacteria, which is initially measured at 5,000. It increases by 12% every hour. So 1 plus 0.12 or 1.12 will be the common ratio. We write that one down as 5,000 times 1.12 to the n minus 1. Now very quickly, if we put that into our calculator, we can see that 5,000 becomes 5, 6, etc., etc.